Rockingham Studios presents a Meets Steel education production from the Second Life University of Patton Bay at Midnight Springs, Washington. Real-life learning in Second Life. A wild world of science video read-along. Chapter 2-2, Populations and Ecosystem Carrying Capacity. With course instructor, Professor Callum Dixon.
Greetings, my fine young scientists, and welcome back. In this unit, we have started our investigation into the ecology portion of our course. Today, we will continue our journey into the dynamic processes and relationships that exist in our living world by completing the read-along portion of your Chapter 2-2, Populations and Ecosystem Carrying Capacity assignment. Remember to press pause or rewind the video as needed during your learning. Now let's get started, shall we? Chapter 2-2, Populations and Ecosystem Carrying Capacity. Controlling populations. When there are plenty of resources available in an ecosystem, populations will grow. When resources become limited, the growth of a population slows down. If resources continue to decrease, the population will begin to decline. The number of organisms in a population that can be sustained in an ecosystem is known as the carrying capacity. Carrying capacity of a particular ecosystem may change depending on the presence or absence of limiting factors. For example, during the summer, the carrying capacity may be higher than during the winter because food is more available. The factors in an ecosystem that control population growth are called limiting factors. Limiting factors can be abiotic, rainfall, temperature, forest fire, or they can be biotic, meaning living organisms and their interactions. Question 3. Give 3 examples of abiotic limiting factors. 3 examples of abiotic limiting factors include rainfall, temperature, or forest fires. Limiting factors are classified as density-dependent limiting factors or density-independent limiting factors. Density-dependent limiting factors are those that have their greatest effect on population size based on how large a population is in that ecosystem, how dense the population is. These include availability of food and water, the presence of a disease or parasites, the number of predators in the area, and competition within and between populations. Density-independent limiting factors are those that affect the populations of organisms, regardless of population size. Density-independent limiting factors include natural disasters, forest fire, flood, storms, and human disturbances. Question 4. In the table below, give examples of density-dependent and density-independent limiting factors. Examples of density-dependent limiting factors, which have the greatest effect in denser populations, include availability of food and water, the presence of a disease or parasites, the number of predators in the area, and competition within and between populations. Examples of density-independent factors, which affect populations regardless of population density, include natural disasters such as forest fires, floods, or storms, as well as human disturbances. Graphing carrying capacity. If a population existed without the controls of limiting factors on its size, the population would grow exponentially. This means that the rate at which the population increases would also increase. Graphically, this can be seen by the J-shaped curve in the graph below. Ultimately, however, limiting factors will keep a population from continuously growing exponentially. When resources are limited or other limiting factors exist, the J-shaped curve will begin to curve in the other direction. While the population is still growing, the rate at which it is growing is no longer increasing and, in fact, decreases. We see it as the S-shaped curve in the graph. This is logistic growth. When the growth rate decreases or the population itself begins to decline, resources may recover, allowing further population growth. If resources do not recover, a population in that ecosystem may die off or leave the area. Chapter 2-2 Essential Understanding Summary. When resources are plentiful, a population will grow exponentially, showing a J-shaped curve in the graph. When limiting factors kick in, population growth slows. This is logistic growth and shows as an S-shaped curve in the graph. Population overshoot occurs when a population exceeds its carrying capacity and will lead to population decline. Density-dependent limiting factors limit population growth based on the density of the population. Examples include disease, parasites, and competition. Density-independent limiting factors affect population growth regardless of population density. Examples include natural disasters and human disturbance. Carrying capacity is the number of organisms in a population that can be sustained in an ecosystem and may change with a change in the presence or absence of limiting factors. This concludes the reading portion of your chapter assignment. Work independently to define the chapter's key vocabulary terms. When you have finished, answer the chapter review questions and submit your assignment for assessment and feedback. Until next time, be safe, make good choices, and I'll see you again soon.